Hello students, hope you all are doing great. Today we are going to study motion part 3. This is chapter number 8 of class 9th science book. It's NCERT book and CBSE based syllabus. We are mainly going to study about graphical representation of motion. Under this particular topic, we are going to study distance time graph and velocity time graph. You can see students, we are going to study mainly about distance time graph first, and later on we will study about velocity time graph. Now you can see this is the first graph which is shown here in the picture. This graph is for object is at rest and located at origin. You can see on x-axis we have taken time, whereas on y-axis we have taken distance. Like you can see in the graph, this red line is showing you the graph which is actually made on the x-axis. So whenever the object is at rest, means it is not in motion and it is located at origin O, then the graph looks like what it is shown in the picture. Next graph you have here, object is at rest and located away from origin. So the graph will look like, you can see here in the picture, on x-axis we have taken time, whereas on y-axis we have taken distance. So after 1 unit time, the object is located 100 units away from the origin. After 2 unit time, means it can be 2 seconds or 2 minutes, it is again at the same position, that is 100 meter away from the origin. And after 3rd and 4th unit time, means suppose after 3 seconds or after 4 seconds also, again the object is located at the same place, means at same distance from the origin. It means the object is not at all moving, it is at rest and it is not at origin, but it is away from origin. Like here in this particular graph, this is 100 units away from the origin. So through these kind of graphs you can easily interpret what is the position of the object, whether it is in motion or whether it is at rest. Next we are going to study about distance time graph of an object moving with uniform speed. You have studied in earlier the previous videos about uniform motion, that is the object when it is traveling equal distances in equal intervals of time, it is said that the object is showing uniform motion. It means the speed of the object is not changing, it is moving with the same speed. So here in this particular graph you can see that the object is moving equal distances in equal intervals of time. Like you can see in the table, in first hour it is moving 50 kilometers, in second hour it is moving 100 kilometers, in third hour it is moving 150 kilometers, and in fourth hour it is moving 200 kilometers. And when you join all these points, you will find that it is a straight line, which clearly depicts that the object is showing uniform motion or it is moving with uniform speed. So this is very much clear from the picture, and even you can see in the table, if you divide 50 by 1 you get 50, 100 divided by 2 again you get 50, 150 divided by 3 again 50, and 200 divided by 4 again 50. So the speed remains same every time. Now we see the next one. This is about distance time graph of an object moving with non-uniform speed. This time you are getting another table where you can see in 1 hour object is moving 20 kilometers, in second hour it is moving 70 kilometers, in third hour 150 kilometers, in fourth hour or after 4 hours you can say it has traveled 200 kilometers. So what kind of graph will we get? Let us see. Yes, you are getting this kind of graph which is nothing but a kind of curve. So it is not at all a straight line. So we can conclude that whenever the speed is not same, it changes with time. Means when an object travels unequal distances in equal intervals of time, the object is said to have non-uniform motion or non-uniform speed. Right? Now see next. Now we have few important points about distance time graph. When a body is at rest, distance time graph is a straight line parallel to the time axis, what you have already seen in the very first slide. Then when a body is in uniform motion, the distance time graph is a straight line inclined to the time axis. This is very important to note. When a body is in uniform motion, the distance time graph is a straight line inclined to the time axis. The slope of a distance time graph represents speed or velocity of the object. Here you must have noted there is a new term, that is slope. This term is very important, but don't get confused. Slope actually means the ratio of the y scale and the x scale. Means like we will be solving one problem by the end of this particular video, and you will come to know how to find the slope, and slope of a distance time graph represents speed or velocity of the object. It is nothing but the ratio of the y scale and the x scale, or you can say change in distance upon change in time. Then speed of object is given by v equals to S2 minus S1 divided by T2 minus T1. S2 means the distance travelled, the final distance travelled, and S1 is the initial distance travelled. Time T2 is the final time, T1 is the initial time. Next we are going to study that when a body is in non-uniform motion or accelerated motion, the distance time graph is a curved line, what you have already seen in the previous slide. Next one is, which object is moving faster? So here comes a graph. This is again a distance time graph. This graph is an exercise for you. You can see there are three different colored lines. Green line is for the first object, blue line is for the second object, and the third line, that is the red line, that is for the third object. So there are three different lines showing the distance time graph for all the three different objects. You can see the green line, that is for the first object, is a straight line. And if we mark the angle, it is like this. Okay. Now the second object, it is showing you the blue line. You can mark this angle, and the third object, that is making another angle with the time axis. All the three graph lines are making different angles with the time axis. So the green line shows a fast steady speed moving from 0 to 100 meter in 5 seconds. The blue line shows a journey with a stop and a return to the starting position. The red line shows a journey starting 2 seconds later than the other two with an initial acceleration, then a deceleration, and then stop. Means you can compare these three angles. Okay, and you can see very clearly that the green line is making the biggest angle. So just looking at the magnitude of the angle, you can easily say the one which makes bigger angle moves faster, and the one which makes a smaller angle is the slower. Okay, so here in this particular graph, the object which is showing green line is the fastest one, and the object which is showing you red line is the slowest one. Now one more thing you can note here, that this blue line is showing you steady speed, means in this particular portion the speed is not changing. Then you can see the middle part of this graph is showing a parallel line to the time axis. It means the object has stopped for some moment, means between 5 seconds to 9 seconds the object is not moving, and then again it starts moving, and this time the speed is you can say it is traveling again, but this time the speed is again steady, and it returns to the starting position once again. So you can interpret the distance time graph in this manner. And a third one, it is showing you acceleration in the previous part, and later on it shows you deceleration, and then finally it stops, because you can see that there is no change in the position of the object. Then we come to velocity time graph. Velocity time graph of an object moving with uniform velocity. You can see in this particular figure, and there is a corresponding table also. Time is given in seconds, whereas velocity is given in meter per second. Time is there on the x-axis, whereas velocity is there on the y-axis. So in first 2 seconds the velocity of the object is 40 meter per second. In 4 seconds it is again 40 meter per second. 6 seconds again 40. 8 seconds again 40 meter per second, and so on. So you can see that throughout its journey it is moving with the same velocity, that is 40 meter per second. And here comes the graph. Like you can see, it is a straight line which is parallel to the time axis. It means the velocity is not changing, it is constant, and whenever the velocity is constant, it means it is a case of zero acceleration, which you have learnt in your previous part of the chapter. Next one is about velocity time graph of an object moving with uniform acceleration. Let us see this one, and there is a corresponding table also. In 2 seconds it travels 6 meter per second. The velocity is 6 meter per second in first 2 seconds. In 4 seconds the velocity is changed now, and it is 12 meter per second. 6 seconds it is 18 meter per second. After 8 seconds it is 24 meter per second, and after 10 seconds you can find the velocity is again changed, and it is 30 meter per second. So you can see very much clearly from the table that the velocity is continuously increasing. And have you noticed that velocity is increasing equally in equal intervals of time? In every 2 seconds there is equal increase. There is increase of 6 meter per second. 12 minus 6 gives you 6. 18 minus 12 again gives you 6. 24 minus 18 gives you 6. 30 minus 24 give you 6. Now you get a straight line. So it is a case of uniform acceleration, means there is increase in velocity, and every time there is equal increase in the velocity. Now you have velocity time graph of an object whose velocity is decreasing uniformly with time. So this graph is again very clear. You can see initially the velocity was 20 meter per second, but slowly it decreases. It keeps on decreasing, and finally it reaches 0. So, and every time there is equal decrease. Right, so it is a case of uniform deceleration, which is also known as uniform retardation. Next, we are going to study about velocity time graph showing non-uniform variation in velocity of the object with time. So, wow, this is very much clear from the graph that first part of the graph is a case of uniform acceleration. Then you see the second part, there is uniform deceleration or retardation. Then again some part is showing you acceleration, and again deceleration. So it is a kind of graph which is a combination of acceleration and retardation. So you can say the velocity is changing. There is variation in the velocity of the object with time. So this is a case where you can say that it is non-uniform acceleration. Next one is velocity time graph of an object when its initial velocity is not zero. How does it look like? It looks like this graph. When the initial velocity is not zero, please note students, this red line is the main graph line and it is not starting from origin, it is away from origin. Like you can see here, it is away from origin. This is the origin and the graph starts from here. Means the initial velocity is here and finally it reaches this particular point. So it is very important to note that the area, the shaded portion, which is the you can say area under the main graph line, this is the shape of a trapezium, and with the help of the area covered under the velocity time graph, you can even find out the distance or the displacement of the object. This is very important to note. Like if you are asked about find the distance traveled by the object, then you need to find the area of this trapezium and you will find the distance or the displacement of the object. This is very important information which we receive from velocity time graph. Now some important points about velocity time graph. When a body is moving with a uniform velocity, the velocity time graph is a straight line parallel to the time axis. The magnitude of displacement or distance moved by the body is equal to the area enclosed by the velocity time graph and the time axis, as we were told just now. When a body is moving with a uniform acceleration, the velocity time graph is a straight line inclined to x-axis. And the slope of velocity time graph represents acceleration of the body. And when a body is moving with the variable acceleration, the velocity time graph is a curved line. Now, here comes a sample problem on distance time graph. Find the speed of the object as it moves from A to B with the help of the given graph. This is a sample problem for you. And let me tell you how to find out the speed of an object with the help of a distance time graph. As we were already told that we can find out the speed of an object with the help of a distance time graph. So it is very simple, students. What you need to do, like you want to calculate a speed, so like here it is already mentioned from A to B, you have to find out that what was the speed of the object. So you will be finding speed equals to change in distance upon change in time, as you were told about slope. So slope is nothing but the change in distance upon change in time. So change in distance means, like you can see, the final distance is 40 meters and the initial distance is 20 meters. For this particular portion, you can see there is a black line and 40 minus 20 gives you 20, like it is written here 20. Now change in time. So this is the particular time interval. 10 seconds minus 5 seconds gives you 5. So 20 by 5 give you 4 meter per second. This is the velocity of the object or the speed of the object. So with the help of a distance time graph, it is very easy to calculate the speed of an object or velocity of the object, right? So I think it is very simple to understand. You can find very easily. Now here another sample problem we have, but this problem is based on velocity time graph. A body is moving uniformly with a velocity of 5 meter per second. Find graphically the distance traveled by it in 5 seconds. So you can see there is a graph shown where on time axis, on x axis we have time and on y axis we have velocity. So if the object starts from origin and like you can see that the velocity of the object is 5 meter per second and in 5 seconds After 5 seconds again the object's velocity is 5 meter per second. So since beginning the velocity is same, there is no change in velocity, right? There is no change in velocity. It is 5 meter per second, and you can say that area of this graph can be found by length into breadth. That is, here on the breadth is like we have taken it like b, and the length it is taken as h. Okay, symbols you can take any. You know that as you have learnt earlier, that the area covered on the velocity time graph gives you the distance traveled, right? So this particular shape, the area you can see under this graph is a rectangle. So you will use the formula of rectangle, that is length into breadth. Here we have some different symbols, but don't get confused, it is length into breadth. And then how to find out? Let us write distance traveled equals to area of rectangle, which is length into breadth, and you can see the length is 5. Right, the length is 5 and the breadth is also 5. So 5 into 5 gives you 25 meter, and that is the distance traveled by the body. That is 25 meter. The body travels 25 meters in 5 seconds. So today you have learnt about distance time graph and velocity time graph, and you have gathered many important informations about these two types of graphs. You all are suggested to practice such kind of sums and to draw those kind of graphs in your notebook, so that you become perfect and you gain confidence. Now next time we will be studying more. Till then, stay healthy, stay fine. Thank you.